right? In case it's some of your first time or you can't remember how to read off some of these things, right? So the chi-squared distribution, right? Remember today you want to take a look at the chi-squared goodness of it, right? So the chi-squared distribution looks something like this, right? And for us to, remember we're trying to see if some data models a particular distribution. So either is true or either is false, right? Either is true or false. How you figure it out is by creating something called a rejection region, right? Something called a rejection region. So we need a value that if we get outside of that value, we're going to reject it, right? And that value is this chi-squared value by some degrees of freedom significance level. So anything inside there, anything in that shaded region, we're going to reject. So the first thing that we need to remember is we need to remember how to get the value from the table. So chi-squared, let's say we have chi-squared, 4 degrees of freedom, 5% significant level. You have to go to a table, right? You have to go to a table, and anybody could just check the table that we have there. It's not a normal distribution, although it's slightly sloped a little bit like that, right? Anybody could check the table that I sent back in the group, right? Check and see if it's shaded here or if it's shaded here. Is it shaded like A or is it shaded like B? The table I sent in the group. Yeah, you all checked it? Which part shaded? A. Okay, all right. So we'll work with this table, right? A is shaded, you all said. So if A is shaded, you're going to a chi-squared table. And on your chi-squared table, we're trying to read this, right? So the top part that you're going to read off is 0.95. That 0.95 corresponds to 5%. And then you're going to go to the outside column and come down until you reach 4. And where they both intersect, that will be the value for chi-squared, 4 degrees of freedom, 5% significant level. How much you all got there? 9.488. So what they're saying is that if we do a test, we do a chi-squared, and we get a value more than 9.488, we're going to reject whatever, we're going to reject this statement here. Okay? Kaylin, you got that value? Yeah? Okay, as practice, just take one more. Chi-squared, 1%, 2 degrees of freedom. Tell me what you get, please. Right? Think about what you will read, right? For 5%, you read off 0.95. So what percentage should read off something? Right, this message how much you got, right? How much you got? 9 point, nice. You get 9.210. Okay? So that's the way I read it off, right? You okay read it off now? Especially you, Kaylin. Everybody else here did it already, yeah? You could read the table. Not really. So remember, well, you probably wasn't paying attention, right? So pay attention now. Which table? Oh Lord. So you really wasn't paying attention. If you check back in the group, the last piece of paper, the last PDF that they sent, when we were reading off the normal, you're looking through there and you would see the normal, you would see the chi-squared and so on. Go to the chi-squared table. You found it? What's that, Gil? Right? When you find the table to read off chi-squared, 5%, 4 degrees of freedom, you're looking for the top column. On the top row there, you're looking for 0.95. And then on the first column, you're going down until you see 4. And you're looking to see where those two intersect. And you will see 9.488. Is that true? Okay, you got it. Very good. Just do one more for me now, please, if it's not too much trouble. The last one was 1%, right? Do a chi-squared 10%, 3 degrees of freedom. Kaylin, you alone. What you got? Nobody else have to message besides Kaylin. Okay, amen, Kaylin. So you could read it. Pay attention now, right? I know you didn't pay attention during pure maths. Just pay attention during this, right? All right, so that's the way you read. So we could read off a table. Now we need to learn, right? Now we need to learn how to do the actual test. Okay. So the steps of the test, I'll write it out in full after, but I'll give you the general steps. The first step is to make a null hypothesis and your alternate hypothesis. Right? If you remember, chi-squared is an example of hypothesis testing, right? Using the chi-square distribution, of course. So the null hypothesis is always going to say the data is distributed in a particular way. Right? It could be Poisson normal, right? And H0, it is not, right? H1, the data is not. Nice. That's your H, right? Next step. The next step that we need to do is, the next step is to get the critical region, right? The next step is to get the critical region. That's this thing I was showing you all a little while ago. That's this part here. We need to get this chi-squared value. So we need to get the significance level and the degrees of freedom, right? And I'll show you how to get the degrees of freedom in a little while. Okay. So once we have the rejection region now, we need to get the chi-squared calculated value. To get the chi-squared calculated value, we're going to sum up the observed minus the expected, square that, and divided by the expected value. Okay? So we need to remember those little things. And then after do that, we're going to compare chi-squared calculated with chi-squared significance, freedom, degrees of that, right? And then make a conclusion, right? It shouldn't be too difficult. It's very similar to what we did before. All right, and then we're going to make conclusion. All right, ready? So screenshot that. In Kaylin, in your case, write it down. And then let's take a look at how to work this out. Yeah, anybody writing now? Pew, 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 pew. Somebody. Ooh, 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 ooh. All right, changing this, right? So let's try one. So the number of goals scored by a football team. Right? So goals is the number of goals, and this is the number of matches. So 0, 1, 2, 3, 4, 5, 6, 7. And the number of matches played are 100 matches, right? 14, 18, 19. Sorry, that's 29. 18, 10, 7, 3, 1. Just do me a favor now. Add up the bottom row and make sure it sums to 100, please. Correct? You got 100? Yeah, okay, nice. I wanted to make sure. Okay, nice. So here's how you want to do. You want to do a goodness of fit test. You want to do a goodness of fit at 10% significance level. That's the alpha value, right? To determine whether or not the distribution follows a Poisson of parameter 2. So we're starting with the H naught. Where am I going to fit all of this in, boy? Anyway, we'll see how it goes. H naught is that X follows a Poisson distribution. And your H1 is that it doesn't follow. Right? X is not, X doesn't follow, right? Right? X doesn't follow a Poisson parameter 2. Okay? So we need to work out a few things. So the first thing you do, you don't get a chi-squared value first. Huh? You'll get a chi-squared value after you set up the table. Okay? So the first thing that we need to do is we need to get the chi-squared calculated value, right? At what did I say? Sorry, at 10% significance. Okay? We need to get that calculated value. Right, but its significance don't matter as yet. Hold on. Huh? Right, so to get the calculated value, we have to get the observed minus the expected, square that value, and then we are going to divide it by E and then sum it all up. So all these values here that you are seeing, all these values are your observed values. So we already have the observed values. Now we need to figure out what is the expected value based on this distribution when 0 goals are scored. Okay? So how are we going to do that? What we have to do is find the probability when X is 0. Right? So we have to find the probability when X is 0 using this distribution. So when X is 0, that'll be E to the minus 2 by 2 to the power of 0 all over 0 factorial. How much is that? Check it from the calculator now, please. Ooh. 0.135. Nice. So that's the probability. So what will be the expected value? Well, the expected value when it's 0 goals will be the probability multiplied by the total possible. Remember N by P? N by P will give you the expected value, right? So it's 0.135 by 100. So it means that is 13.5. 13.5 is your expected value. So your expected value there is 13.5. So that is the problem when we're doing the questions. We have to calculate the probability for each one and then work out the expected value. All right? So I want you to do me a favor. And there's plenty of work, but we just go and do like 2 today and we're done. We're doing 1 in Poisson and 1 in somebody else. Right? So do that for me, please. right? Work out for each one, right? And then just try to make sure you round off consistently because you see, it has to sum to 100, the expected. So just be careful when you're rounding off. All right, so let's just see if the table looks something like this, huh? Right, observed values and the expected values, right? So when I was 14, we worked out 13.53, 18, 27.07. When I was 29, they should have gotten 27.07 again. When I was 18, when I was 18 is 18.04. When I was 4 now, I got 9.02. When it's 5, I got 3.61. When it's 6, 1.21. When it's 7, it's 0.45. Anybody got those values there? Last 4 observed were, oh, sorry. I watched the wrong part of the table. It was 18, 10, 7, 3, 1. Thanks, Christopher. Yours, yeah, it was probably we just round off bad, but you just had to be careful and round off consistently so that it adds up to 100. So let's assume it looks like mine, right? We have one little problem. You see this here? The chi-squared test is invalid here. It's invalid for expected values less than 5. So what we just do is instead of leaving them like 5, like 3, 3.61, 1.21, and so on, we combine all of this into one. And we call that, I think this was 5, 4, this was 5 goals, 7 was 5 goals, then 6 and 7, and we call this more than 5 goals, right? And we would end up with 11, and the expected value to be 5.27. Okay, so we're not using the values less than 5. We have to combine them with the nearest, with the ones underneath, right? If we combine the 3 with the 9, it don't make sense because the 1 and the 0.45 still by itself. So if it combine here and it combine here, it don't make sense, right? So the best thing to do is just combine the bottom 3 and the value is more than 5. Okay, any follow went on there? Okay, now we have to go to the next part. The next part is to find the observed minus the expected, square it 1 time, and then work out the expected. Do that all in the calculator. The first value I have here is 1.571. sorry, did I add that up right? I think I make a mistake. Somebody can just check it from there. So it's 14 minus 13.53 all squared divided by, yeah, it must be something smaller. How much you got there? 0. What? Right? Remember, we're ignoring this now, right? 0.0163. Yeah, that could work. Right? Then you work out the others. Then you work out each one. You have 1, 2, 3, 4, 5 more to work out, then total it up. And then that will be a value for, right? That will be a value for the chi-squared calculated. Okay, so I think this is 3.038. Yeah, find it back. So it's 0.137. This value is small, so I think it's negligible. The value underneath that is 0.106. And this value here is 6.230. Right? When you add up all of this, you get 9.529. This here is your calculated value. Right? It's a chi-squared calculated. That's the value that you're going to check and see if it's inside the rejection region or not. So how do we get the rejection region value? Well, chi-squared, we know it's at 10% significance level. How do we get your degrees of freedom? To get your degrees of freedom, real simple. It's a number of classes or a number of groupings. This is 1 group, 2 groups, 3 groups, 4 groups, 5 groups, 6 groups. So it's the number of groups or classes minus 1. So N is the number of groups or classes, right? Anything you want to call it. Minus 1. So we have 1, 2, 3, 4, 5, 6. So that's 6 minus 1 classes. Right? 6 minus 1 classes. So you go to your calculator and you read off, you go to your table and read off chi-squared 10%, 5 degrees of freedom, and that will give you your rejection region. How much you got there? 9 point what? Right, 9.236. So that critical value is 9.236. Right? So we're going to reject H naught. So let's say the H naught, we're going to reject it if the value is larger than this. And your chi-squared calculated is inside that region because it's 9.529. So here what you will say? You will say since the chi-squared calculated value is more than the chi-squared value from table, it falls in the rejection region. So we reject H naught. So in essence, here's what we're saying, right? I'll write it for you in a different color. Right? So since chi-squared is more, chi-squared calculated is more than 9.236, we're going to reject H naught. We're going to reject H naught. Right? And we go with H1 basically. We reject H naught and say that the number of goals cannot be modeled, right? So we'll say cannot be modeled, right? I don't have any more space. So put cannot be modeled by Poisson with parameter 2. That's it. That is what you're trying to prove. You okay with that? The hardest thing is to get the expected values. Any questions, anybody? Anybody confused anything? So the difference here is that the main thing here is that you could use any distribution. They could ask it for Poisson, they could ask it for normal, they could ask it for a uniform, they could ask it for geometric, any distribution. All that will change is the e-values. Right? If it's a uniform distribution, I know we didn't really practice much of it, right? But if it's a uniform distribution, it means that the probability for each event is the same. Those are real easy. Those are real fast to work out, right? So for a uniform distribution, it means that every single one of the probabilities is the same. All right? So I just wanted to remember that, right? If it's a uniform distribution, all of them have the same probabilities. So therefore, they will have the same expected values, right? So as a quick little thing here, I want to try one more before we wrap up. I know we're ready for holiday or something already. Right? Anybody writing this? Nobody writing, right? All right. So right, try this here for me. Right, try this, please. Let's just do all this and we good to go. Yeah, Olive, any answers? Y'all done? Let's finish it up now. We just send in the final thing. So what y'all got here for the expect? What y'all got for the total of the observed? 250? Yeah, 250, nice. Because it's a uniform distribution, right? Uniform, the probability of all is the same, right? So 1, 2, 3, 4, 5. So it's 1/5 by 250. So they all are 50. Right? Uniform is the best type to get because they're real easy. Right? So that's 250. Now we want to get the chi-squared calculated. How much you all got for the chi-squared calculated? Kaylin? How much you got for the chi-squared calculated? Still doing it? Moving so slow, like you now start. Anybody have the chi-squared calculated again? I've drew the answer so far. Right, we do have to merge any cells here, right? So that will be chi-squared 1%, degrees of freedom 1, 2, 3, 4, 5. Right? So we chi-squared 5, 1. Yeah, so chi-squared calculated. Anybody else have it? Grant? Gil? Raul? Hurry up. I'm giving you a few minutes again. Hurry up, please. Send your values, right? Chi-squared calculated, chi-squared rejection region, and tell me what's your final decision. All right, so the calculated value I have here is 5. Anybody else got 5? And the chi-squared value on the table, I think Jude have 13.28. Anybody got that? Nice. Right, Kaylin, try it back over and check your readers. You can take a picture and send it to me as well, right? Right, the chi-squared calculated value is outside, so therefore we do not reject at the 1% level and conclude that a uniform distribution fits the tea drinking preference, right? And we accept each one, right? Of course, we do not reject H naught. We do not reject H naught, and you see that a uniform distribution fits the tea drinking preference of the 250 persons, right? So it's fair to say that it fits a uniform distribution. Are we good to go? That is your chi-squared. In this case, there was nothing for us to join together or anything, right? You look at the wrong table. What table are you looking at? You sleeping? You lying on a table and sleeping? All right.